Hello class, today we are going to be looking at logarithm, and the logarithm we are looking at today is a kind of logarithm that is not expressed in base 10. So ordinarily logarithm is expressed in base 10, but a situation where you have whereby logarithm is expressed rather than base 10, so this definition comes to play, and it's very simple. What you just have to do is to, okay, before we even go, can you call this expression on the board? Log a n. Is that correct? No. So what you say is log n base a. So log n base a. So it means that then this x shows the index. In how many ways can we raise this x to equal this n? So this is the index. This is what I'm saying. So if you want to get this definition, the n, we count down first, equals, then the subscript here, I said it's log n base a. The base here will come outside, power the x. For instance, let's take log 8 base 2. Sometimes the examiner will give you equals x or y, and sometimes nothing will be there. So you should do that. It means you have to do that yourself. So let's assume the question is like this. So what you just have to do is, as I said, how do you pronounce this expression? Is it log 2 base 8? No, log 8 base 2. I said log 8 base 2. So what you do now is the 8, don't forget, n comes down. So the 8 comes down, followed by equal sign. The log will always come down. Followed by equal sign. Then the base. What is the base here? 2. So the 2 will come here. Power what? Nothing is here, but it's going to be x. So it now means that we want this 8 to also be in base 2. So we want this value here and this value here to have the same base. And the base here is 2. So how can we convert 8? So that we'll be having 2 raised to power something and must equal 8. So 2 raised to power what will equal 8? So 2 raised to power 3. 2 times 2 for 4 times 3, 8. So we say 2 raised to power 3 is still the same thing as 8 equals 2 raised to power x. So that 2 can cancel out 2. Then we can now say 3 equals x. So, or x equals 3. So this is our final answer. It's simple. This is what we are going to learn before we go to law of log. Now, let me give you one more example. Let's assume we have log 1 over 2 base 2. So, there is no value, there is no equal sign x here, so you put it yourself. So, what are you going to do first? The 1 over 2 will come down, equal sign, then the base raised to power what? X. How can you ensure that the value here have base 2? Because this is 1 over 2. How can we make it to have base 2? So we just say 1 over 2 is the same thing as 2 raised to power minus 1. That is why you need to have the knowledge of indices before you can solve this logarithm rather than base 10. Because when you convert it in indices, you should know that 1 over 2 is the same thing with 2 raised to power minus 1. So we can now have 2 power x. 2 we cancel 2, they have the same base now. We are having what? Minus 1 x, or x equals minus 1. So that is, you can have a lot of question then. Then when you have, for instance, you have log 100 base 10. How do you solve it? Can anybody solve it for us? So if you just want to do this, you still bring it down, right? 100 equals base 10 raised to power x. What base? In how many ways can you raise 10 to give us 100? 2 times 10 raised to power 2 equals what? X. Equals 10 raised to power x, right? So that's x equals what? 2. It's as simple as that. So now in our next video we are going to go to addition law, subtraction law, and many others under this log rather than base 10. Please subscribe to get more of our videos.